Okay, so in the last lecture we have discussed we have started discussing decision based model, and we have seen two cases on a infinite chain network. Two cases, one setting A was 3, B was 2 and C was 1. Another setting A was 5, B was 3 and C was 1, and we have seen how two different adoption strategies emerged, right, over time, over iteration. Now let's make this thing generic. Okay, so what we do here, we have three basically parameters, so to say, right, and let's make one parameter fixed. Let's assume that B is 1, right, and A is A and C is C. How you can do that? Say, let's say A is 3, B is 2, C is 1. So we can easily make B equals to 2, and then A would be 3 by 2, right? So let's fix B. Let's assume that B is 1 and the other two parameters would remain same, A equals to A and C equals to C. Okay, and we will discuss two cases. Case 1 is like this. We will decide use strategy depending on use neighbor strategy. U has two neighbors. The one neighbor has adopted A, other neighbor has adopted B, and case 2, U has adopted one of U's neighbors has adopted AB and the other has adopted B. I am assuming that you have understood the previous lecture and you have memorized the payoff table, right? A quick recap again in case you have forgotten. So for single strategy, right, if both the parties have same strategy, right, have adopted same strategy, then the payoff would be the corresponding payoff. Say both of them adopted A, then this would be A payoff, B then B. If both of them have adopted different strategies, then 0, right? Multiple choice strategy, if you have adopted AB, if one of your neighbors has adopted, say, A and you have adopted AB, then the payoff would be A, but the cost would be C because you have adopted both the strategies. If your neighbor has adopted B and you have adopted AB strategy, and the payoff would be B plus the cost. And if both of them have adopted, both you and your neighbor have adopted AB, then the payoff would be max A comma B minus the cost, right? That's the total payoff. Okay. Now what we will do, we will see what happens. Okay, so let's take case A. Okay, so case A for node U, let's say U has adopted A, strategy A. What would be the payoff? Payoff would be A, because for this interaction A, this interaction 0. If U wants to adopt B, this would be 0 plus 1, because remember A equals to A, B equals to 1 and C equals to C. Okay. If U has adopted AB, then this would be A plus 1 minus C, right? What we will do, we will draw a state space diagram, right? Say this is okay, so this is A, this is C. Okay, now let's look at the breakout points or break even points, whatever. Say when we will see a tie, we will see a tie between strategy A and B if A equals to 1. If A equals to 1, then both of them would be, both this and this, both the payoffs would be 1. So when A equals to 1, irrespective of C's value, right, will be confused between A and B. So through this line, right, if points lie on this particular line, we will be confused between B versus A, which strategy to adopt, because both of them would result in same payoff 1. If, right, let's say when you would be confused between AB and B, okay, AB and B. So B, it is 1. When A equals to C, right, this would be 1, the payoff would be 1. So when A equals to C, you will be confused between strategy B and AB. So A equals to C line in this particular space, A equals to C line would be this one, right. This is A equals to C line, and you will be confused between B versus AB. What about the confusion between A and AB, right? A and AB. When C equals to 1, then this would be A. Then you will be confused between A and AB. C equals to 1 means this point, right? This is C equals to 1, and you will be confused between A and A versus AB. So we know what would happen when we lie on these lines, okay? These are lines on which you would be confused, and you would choose either A or B or AB, whatever, right, depending on the case. If you look at the entire space, right, this entire space, okay, entire space, how many regions are there? This is region A, this portion is region A, this is, so this is region 1, sorry, not A, this is region 1, this is region 2, this is region 3, okay, this is region 4, this is region 5, right, and this is region 6. Okay, so we will decide the strategy in each of these regions. Okay, let's try to understand. Okay, let's look at, let me first erase. Okay, let's look at region 1. Okay, I am going slow, and so that you understand it clearly, right? If you are confused, you draw it on yourself, and you'll get it. Okay, region 1. So region 1, and this is your setting. Okay, you know that if you adopt A, payoff this, adopt B this, and payoff C. If you adopt AB, payoff is this one. Region 1 is what? Region 1 is this part, which is C greater than 0 and A also this part, right? So A less than, C greater than 1 and A less than 1. Okay, this part. Okay, so if C greater than 1 and A less than 1, let's look at things between A and B. Okay, which one will be chosen? Which one is higher? If we choose A, it is A, otherwise 1, right? Now A is less than 1. A is less than 1. So between A and B, B will be preferred. So A versus B, B will be preferred because B is 1 and A is less than 1. Between B versus AB, what would happen? let's see, AB, A is already less than 1, right, and C is greater than 1. So this part A minus something which is greater than 1, this would be negative, right, and you are subtracting a value from A, this would be even less than A, right, and A is already less than 1. So between A and AB, B would be preferred. Okay, and of course we won't need to look at A versus AB because A is already bad, right, A is already a bad choice. So in this region, B will be preferred. Okay, now let's look at the region 2. Okay, in the region 2, what is the case? The case is A is greater than 1, C is also greater than 1, and so this portion, right, this portion C is greater than A, isn't it? If you look at, say, this point, right, this point, you see that C's value is higher than A, right, and below this point A is greater than C. We are looking at this part. Right. Let's look at what happens between A and B, A versus B. Okay, A is greater than 1, right, A is greater than 1, okay, and B is 1, so A will be chosen. So now B is cancelled out. What about A versus AB? Look at this one, okay, look at this one. C is greater than A, right, so A minus C plus 1, right, A minus C would be negative, right, you are subtracting something from 1, so that would be less than 1, whereas if you choose A, it would be A which is greater than 1, so A will be chosen. Therefore in region B, A will be chosen. Okay, similarly if you think of let me remove it. If you think of region 3, what are the strategies? What are the conditions? So C, this part, right, okay, C is greater than 1, okay, A is also greater than 1, okay, and right, and A greater than C. Okay, so what would happen in this case? Think about it. So this is A, right? Now between A and B, the clear winner is A. What about between A and AB? A minus C is now positive, right? And you are adding some positive number with 1. Okay, now 1 plus that positive number, whether this would be greater than A or not. A is also greater than 1. Okay, A is also greater than 1. So what would happen? A would be chosen here also. So this would be A. Okay. Now let's look at region 4, R4. Okay, C is less than 1, this part, A is greater than 1, right. So between A and B, A will be chosen. Between A and AB, what would happen? Let's look at it. So let's look at it here, right. So 1 minus C, okay, C is less than 1, okay, it would be negative. So this would be positive. So A plus some positive component, this would be greater than A. So AB will be chosen. This would be AB. Okay. Similarly, if you look at this part, okay, I am not deriving it. Same thing in this part. What would happen in this part? In this part, A is less than 1, C is also less than 1, right? You will see and you will realize that this would also be AB, and this would be B if you calculate in the same manner. Okay, so this would be the space diagram. This would be the relation between A and C when B is fixed. Okay, so you see that B here, A here, A here. So this part would be A always, this would be AB always, and this part would be B always. What does it mean? From this space diagram, what did you infer? Okay, so initially your strategy was B. If you remember, right? If you remember the setting here, right? Initially your strategy was B, and this was also B, and this was A, right? So, and let's say, and the strategy A is something which actually has come due to this hard behavior. Okay. So, if the cost is, say, look at this region, right? Now, what you are trying? You are trying to propagate A. You are trying to move. You are trying to spread your strategy A, because majority of the users have already adopted B. Only a few adopted A, and you want that A would now spread, right? So if you want to spread A, and if your cost is too high, if your cost is greater than high, nothing would happen, right? People will still adopt B, right? If you gradually increase, if you gradually decrease your cost, right? Gradually decrease your cost and increase the payoff of adopting A, right? You you convince your customers to adopt both A and B. You say that, hey, you are using Amazon Prime, that's fine. You also use Netflix, and look, if you use Netflix, you have a lot of benefit, lot of payoff, right? And you also need to incur a small cost. You need to spend a small amount of money for this. So people will gradually adopt both A and B, and then what you need to do, you need to jump from this region to this region by increasing the quality a lot, quality of your strategy a lot, quality of Netflix a lot, so that even with the increase of cost, people will adapt, people will stick to A, and people will forget about B. Because Netflix now, since now people will start browsing both A and B and see that, okay, A is better, right? So I can spend money for A, that's not a problem. Okay, so then you actually move from this region to this region. Okay, so this is basically the meaning of right, the this space diagram. Similarly, if you look at case B, where this is AB, this is B, earlier it was A, now this is AB, this is B, and you are choosing the decision, choosing the strategy for you, right? The same way. I am not deriving it, but the same way. If you do this thing, you will see this kind of space diagram, where here you will see 6 regions, but here things are a little different. Why? Because of this cost function, extra cost function. So initially we had this, 1, 1 and this. Now we will see from 2, okay, like this. Why? You will understand it, because you will see that when you calculate the breakpoint, right, between A and B, A, B and C, and A and AB, you will realize that that this line is not now C equals to A. This is something different, okay. And these two lines, so this line is C equals to 1, this line is A equals to 2, right. You see here, if A equals to 2, then this would be same, okay. And here if you see that if C equals to A plus 1, C equals to A plus 1, right, C equals to A plus 1, then then you will basically be confused between B versus AB, okay. Sorry, not C equals to A minus 1, A equals to C plus 1, okay. If A equals to C plus 1, then A minus C would be 1, right. A minus C would be 1, and you also have 1 here, so it would be 2. Then you will be confused between A and AB, okay. And if you derive in the same manner, you will see this kind of things emerging. B, A, AB, AB and B. If you merge these two strategies, these two cases, case A and case B, you will see this kind of combined behavior, okay. And if you carefully look at it, what does it mean? In this region, you can't do anything. People will adapt B, people will remain with B, right. With this region, at this region, AB, the strategy AB will start spreading, then will stop. I hope you remember last lecture we had this kind of setting, right, where this one, where although U has switched from B to AB, but then AB has not moved further, right. And these kind of regions, these kind of things are described, right, in this region, okay. This region indicates that A spreads with the help of AB. What does it mean? It means first all the nodes were B, right, then people started switching from AB to B to AB, then AB to A. This is something we also discussed, right, here. In this case, when A goes to A was 5 and B was 3, right. So A will eventually spread, but with the help of AB, and that would be the ideal situation. So you can't penetrate the market directly. You actually have to convince your customers that why don't you also adopt my product, and gradually see what happens, okay. And at the final stage, A would start spreading without the help of AB, right. So this generic model actually gives you an idea about how strategy is spread and how things products will be adopted, your company would penetrate the market, and what would be your optimal strategy depending upon the payoff, and depending upon that you also decide the payoff A, B, C, etc., payoff and cost. Okay. So we stop here today. In the next lecture we will discuss a case study about the decision based strategy, and then following this we will discuss other models which are based on probabilistic theory. Okay. Thank you.